So here's the plan for the day. We're going to go over that assignment from yesterday with half reaction. That's the whole point of the lab that we're going to do today. So a lot of times, especially in redox reactions, they can get pretty complex. But it's simple if you just keep in mind, hey, something has to be reduced, something has to be oxidized, and the two half reactions have to balance. If you keep that in mind, everything else will kind of take care of itself. So if you look on that first one, you have MnO4, and that's what you're going to deal with in the lab today. You're going to deal with potassium permanganate, bright purple. And then you're going to have H2SO3, sulfurous acid, strong acid, weak acid. Weak, because the only strong acid that looks like that is sulfuric, which is H2SO4. Okay? Now, they also have put in there some hydronium ion. Okay? All that's telling you is that this is in an acidic environment. So the reaction you're going to do today that involves potassium permanganate, you're going to add sulfuric acid to it. The whole purpose of adding the sulfuric acid to it is to give you a bunch of free protons, because it has to be in an acidic environment. Now here's the contrast. To make this happen, it has to be in an acidic environment. And at this point, this is what you should be able to look at and go, well, you have H2SO3. You have an acid in there. Doesn't that make it an acidic environment? It does, but this is a weak acid, okay? So there's some hydrogens there, but they're bound up with the SO3. So what this is signifying is that we're going to add an additional acid that's going to give us a bunch of protons. It might be nitric, chloric. Point being, we need a bunch of protons available to make this reaction happen. Now, over here you get Mn2+, okay? And that's what you're going to do in the lab today. You're going to take MnO4, which is a bright purple solution, and you're going to make it turn into Mn2+. Cool. Now, you're also told that you have HSO4-, and you're going to produce some water. Now, you cannot balance this equation the way it is. You could, you got to go back and forth, and it's just a horrible, painful, you're not going to understand what's going on. So you get in a situation like this, the first thing that you have to do is figure out the oxidation states of everything. If you can't figure out the oxidation states, you cannot do redox. Like you literally, like you want to be on the swim team, great. I can't float. Sorry, you can't be on the swim team. If you want to do redox reactions and you can't figure out the oxidation states of the elements, you can't do redox. You can understand, oh, Leo says GER. Great. What's the oxidation state of manganese? I don't know. Go back to the OSS GER. Here's the stuff tiger on your own. So that's the first thing that you've got to be able to do. Now the rule is start with oxygen. Oxygen always has a charge of -2, unless it's in hydrogen peroxide, which is not what's happening here. So you got oxygen, 4 of those. That's -8, which means the manganese is +7. Okay. Now the manganese is going to go from +7 into +2. So it's going to go from a deficiency of 7 chihuahuas to a deficiency of 2 chihuahuas. So did it gain chihuahuas or lose chihuahuas? Gain. Now, manganese can end up with a whole bunch of different oxidation states. It can be 6+, 5+, 4+, all the way down to 2+. In this situation, we're going to swing this all the way from MnO4 all the way down to Mn2+. So, because the Mn went from 7+ to 2+, is the manganese reduced or oxidized? Reduced. So if you're on the reduction, you just start off with this. You go MnO4, 1- is turning into Mn2+. Okay? That's how that starts. Now, I got 1 manganese, that's cool. This is 7+, that's 2+. So I've got to have 5 electrons. The question being, where do I put the 5 electrons? Do I put it on the reactant side or on the product side? Reactant side, because it has to gain 5 chihuahuas. Okay? Now, we're not balanced in any way, shape, or form because of the fact that I've got these oxygens here. So you balance the oxygens, and this is on that sheet of lecture notes. You have to work this in sequence. Great, I'm going to balance the oxygen. I got 4 oxygens, so I'm going to put 4 waters over here. Great. Now we've got my 4 waters. So, but now I have 8 hydrogens. So this is why it's done in an acidic environment. So now I'm going to put H pluses over there. Now, if this is balanced and balanced right, here's what should happen. Each step should balance on 2 things, charge and number of products, or number of atoms. So if I come in here and go, okay, great, I've got H plus, there's 8 positive charges. I've got a total of 6 negative charges over there. That whole thing over there has a charge plus 2. This thing over here, the only charge that I have is manganese, that's plus 2. That's balanced. Then if the number of particles balance, everything is cool. I got 8 hydrogens, I got 4 waters, 1 manganese, I'm done. So literally, there is no reason to ever miss balancing a half reaction, because you could always check, hey, is this thing balanced or not? Now, the oxidation becomes a little bit trickier. So what element was oxidized? Sulfur. So again, you've got to look at this. So you've got 3 oxygens in here, so that's -6. Hydrogen is always going to be +1. So that means that's +2. So the sulfur in here has a charge of +4. Okay? Cool. Now, you come over here. Now you have HSO4 minus. So over here, you got 4 oxygens at -2. That gets you to -8. That hydrogen is +1, and there's only one of those. But everything needs to add up to -1. So the sulfur over here is +6. So the sulfur went from +4 to +6. And again, if you cannot figure out the oxidation states of those sulfurs within those molecular compounds, you can't float. You're going to sink. Now, so you start off and you go, okay, this is H2SO3 turning into HSO4 1-. You have 2 electrons, okay, because we went from 6+ over here, or 4+ over there to 6+ over there. It means that it lost electrons. So where are you going to put the electrons on this one? +2 electrons. Okay? Now I need to balance everything out. Cool. So in this situation, I've got 4 oxygens on the right side. I've got 3 oxygens on the left. What am I going to do? Add a water over here. Okay? Now, at this point, I need to count my hydrogens. So I've got 4 hydrogens over here. Total 4, 2 and 2. But I only have 1 over here. So what do I need to do on this side? Add 3 hydronium ions, because this is an acidic environment. Okay? So that isn't hydrogen gas. It's a proton. Now at this point, what should everything add up to? The same on both sides, right? So I look at this. What's the sum total of everything on the left side? 0. Here I've got -1. I got 2 negative charges there. That adds up to -3. I got 3 positive charges there. That adds up to 0. Everything's cool. Now we need to add the 2 together. This is the trickiest part. The number of electrons lost has to equal the number of electrons gained. So I've got 5 electrons up there, and I've got 2 electrons down here. That's problematic. But what's the least common multiple of 5 and 2?
10.
So what are you going to have to do with everything up here?
5 and 2.
Multiply everything by
2.
2, and then multiply everything down here by 5. Okay? Now you got to start over. You go, okay, well, that's 16 hydronium ions plus 2 MnO4 minus and 10 electrons, yielding 2 Mn2 plus 8 waters. And then down here, I got 5 waters and I got 5 sulfurous acids, and then I got 5 HSO4 minus, and I got 10 electrons, and I got 15 hydroniums. Cool, that's the tough part. Now we just add them together. Okay, now here's what's going to happen. Notice on this one, I have 15 hydroniums on this side, and I have 16 hydroniums on that side. So basically, they're going to cancel each other out, so I have what?
One on the left.
I only have one hydronium ion left over here. Okay? The whole point of this story is to get the electrons to cancel out. And those do. I got 10 and 10. That's the whole point of the story. Electrons lost equals electrons gained. That's cool. Then, on the waters, I have 5 waters on this side, and I've got 8 waters on that side. So that's going to settle out to what? 3 waters over here. And then it's just a matter of everything else, 2MnO4 minus plus 5, da, 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 da. So again, when this gets done, when you do this whole thing, after you've added them together, how can you at least have a fighting chance that it's right? Charges and particles balance. And I promise you, if the charges and particles don't balance, you can wish all you want that it's right, it's not. Okay? If they don't, like, oh, maybe it's close enough. I'm only off by 1 electron. Who's going to know? Nature? Okay? It's one of the great conservation laws that exist. Charge has to be conserved. Mass has to be conserved. Okay. So if all goes well, you should obviously end up with 3 waters on the product. Now, when you get to the second one with this dichromate, this gets a little bit tricky, and I'll show you where. So on the second one, you have Cr2O7, and that whole thing has a charge of 2 minus, and then over here, that's going to end up at Cr3 plus. So the chromium over here, and this part of it is 6 plus, and that's going to go to 3 plus. So this is where you have to do this in sequence. You have 2 chromiums over here. The first thing that you have to do is balance the number of chromiums. Okay? So I've got to put 2 chromiums on this side. Okay? Balance that first. Then you can deal with the number of electrons. So this is going from 6 plus to 3 plus. But there's 2 of them. So it's the total number of electrons involved. Maybe 6. Okay. So here's the most common mistake that's made on this particular half reaction. You go, oh, chromium is 6 plus over here and chromium is 3 plus over here, and you only put down 3 electrons. Okay? And 3 electrons would be right if there was just 1 chromium going from Cr3 plus or Cr6 plus into Cr3 plus. But it's not. You have 2 of them. So that's why you have to put 6 electrons over on that side. Okay? The most common mistake that's made. And then the same thing is going to happen with the iodine down below. Okay? So if all goes well on that last one, you should end up with 7 waters. Okay, so on that last one, if you balance everything right, you should get 7 waters. So you should have 3 waters on the first one, 7 waters on the second one. Any questions? Once, twice sold, get that handed in. Alex, can you stop that camera, please?